Okay, hi everyone, welcome back to this video series, Comptia Security Plus. Bridge. A bridge is used to separate a physical LAN or WLAN into two logical networks, or to connect two networks together. You do this by physically connecting the device to both sections of the network. The device will then seek out MAC addresses on both sides and keep that information stored in a table. If a person on one side of the bridge wants to communicate on the network, the bridge will decide whether the information should cross to the other side. This eliminates some broadcasting. A bridge often resides on the data link layer. Note that since the advent of switching, bridges have become much less commonplace. However, you may see them connecting two network sections together. That said, security becomes vital. For example, a wireless bridged environment, you might opt for IPsec tunnel between devices. However, if you find yourself in a bridged environment, then you should probably consider a newer, more secure solution. Router. A router connects two or more networks to form an internetwork. Routers are used in LANs and WANs and on the internet. This device routes data from one location to another, usually by the way of the IP address and IP network numbers. Routers function on the network layer of the OSI model. Routers come in several forms. SOHO routers. These 4-port devices used in homes and small offices connect to the internet servers, which can be configured for routing if they have multiple network adapters and the proper software. And most commonly, black box devices such as Cisco routers. Routers are intelligent and even have their own operating systems. For example, Cisco routers use iOS internetwork operating systems. Often a DMZ will be set up within a router, especially SOHO router devices. We speak more about the DMZ later in this chapter. Routers can be the victim of denial of service attacks, malware intrusions, and other attacks can spread these attacks and malware to other sections of the network. Routers can be protected from these attacks in the following ways. Secure router configuration. Most routers are inherently insecure out of the box. This means that they might have a blank default password, easily guessable username, known IP address, default routing tables, and so on. The first line of defense is to configure the username and password so that it's hard to guess and hard to crack. This means very complex passwords. Go through all possible default configurations and lock them down before putting the router on a live network. Firewalls. Firewalls protect against and filter out unwanted traffic. A firewall can be an individual device or can be added to a router. For example, most SOHO routers have a firewall built in, and Cisco Integrated Services Routers (ISR) include the Cisco iOS firewall. Regular routers. Routers with firewall functionality have the ability to block certain kinds of traffic. For example, if ICMP has been blocked, then you would not be able to ping the router. Intrusion prevention systems, IPS. An IPS will not only detect but also prevent directed attacks, botnet attacks, malware, and other forms of attacks. An IPS can be installed as a network-based solution or on a particular computer or some routers. Secure VPN connectivity. Instead of connecting directly to a router, virtual private networks enable for secure connections utilizing IPsec and SSL. Secure VPN connectivity can be implemented with SOHO routers for small organizations, VPN concentrators for larger organizations, advanced routers like ones offered by Cisco or with a Windows server. Content filtering. Content filtering blocks and restricts access to certain websites. This provides protection from malicious websites. Content filtering can be installed as a server, as an appliance, for example, a web security gateway, or on some routers, ACL access control lists. Access control lists enable or deny traffic. These can be implemented on a router and within firewalls, and in some cases the two will be the same physical device. For example, an ACL can be configured to deny any connections by computers that have IP addresses outside the network. ACLs are instrumental in blocking IP spoofing attacks. Network address translation. Network address translation, NAT, is the process of changing an IP address while it is in transit across a router. This is usually implemented so that one large address space private can be remapped to another address space or single IP address public. In this case, it is known as network masquerading or IP masquerading, and was originally implemented to alleviate the problem of IPv4 address exhaustion. Today, NAT provides a level of protection in IPv4 networks by hiding a person's private internal IPv4 address, known as the firewall effect. Basic routers only allow for basic NAT, which is IPv4 address translation only, but more advanced routers allow for PAT or port address translation, which translates both IPv4 addresses and port numbers. Commonly, a NAT implementation on a firewall hides an entire private network of IPv4 addresses, for example the 192.168.1.0 network, behind a single publicly displayed IPv4 address. Many SOHO routers, servers, and more advanced routers offer this technology to protect a company's computers on the LAN. Generally, when an individual computer attempts to communicate through a router, static NAT is employed, meaning that the single private IPv4 address will translate to a single public IPv4 address. This is called one-to-one mapping. It is also important to know the difference between private and public addresses. A private address is one not displayed directly to the internet and is normally behind a firewall or NAT enabled device. Typically, these are addresses that a SOHO router or DHCP server would assign automatically to clients. A list of reserved private IPv4 ranges is shown in table 6.2. Public addresses are displayed directly to the internet. They are addresses that anyone can possibly connect to around the world. Most addresses besides the private ones listed in table 6.2 are considered public addresses. Figure 6.1 shows an example of a router firewall implementation NAT. The router's public address is 207.172.15.50 and its private address is 10.0.0.1. Computers to the left of the router are on the LAN, and all their IP addresses are private, protected by NAT, which occurs at the router. Servers on the internet within the cloud have public IPv4 addresses, for example 208.96.234.193, so that they can be accessed by anyone on the internet. So we can see here's our public address range: class A 10.0.0.0, 10.255.255.255, class B 172.16.0.0, 172.31.255.255, class C 192.168.0.0, 192.168.255.255. And you can see here server 208.96.234.193 and 208.96.234.194, internet 207.172.15.50 10.0.0.1 and so on and so forth. Keep in mind that most internal networks, meaning LANs, are either subnetted or are classless in nature. It's important to know the private IP ranges and the classes, but just remember that classless is very common, especially in larger networks. You should also know the categories of IP version 6 addresses. Table 6.3 provides a review of these types. Keep in mind that a standard private range for IPv6 is FE80:/10, which spans addresses that start with FE80, FE90, FEA0, FEB0. This is the default reserved range of IP version 6 addresses that computers on LANs and behind a firewall will be assigned from. Type of IPv6 addresses: unicast. Global unicast starts at 2000, link local :1 FE80:/10, address assigned to one interface of another host. Anycast, structured like unicast addresses, address assigned to a group of interfaces on multiple nodes. Packets are delivered to the first interface only. Multicast, FF00:8, address assigned to a group of interfaces on multiple nodes. Packets are delivered to all interfaces. There are risks involved with IPv6 auto configured addresses. Once a computer is physically connected to a network, it can easily obtain an IPv6 address without any user interaction and begin communicating with other hosts on the network, perhaps in an insecure manner. To avoid this, consider using 802.1x authentication, which stops IPv6 traffic until the host is authenticated to the network. Also consider using encrypted tunnels and network adapters that are certified for secure wired or wireless transmission. Last word about IP security. Both IP version 4 and IP version 6 have security issues, and both have various ways that they can be secured. Don't be fooled. Both types of IP networks need to be designed with security in mind. For example, IPv6 has IPsec support built in, but that might not be the best method of security for your organization. IPv4 also can make use of IPsec, and in that aspect can be just as secure as IPv6, but support isn't built in, so we might choose to implement alternative security methods for IPv4. Many networks use both protocols, and though one is working in a secure manner, that doesn't mean that other protocol is protected. Remember to design both types of IP networks to address all security concerns and test them thoroughly on multiple platforms. Network zones and interconnections. When designing your network, think about all the pieces of the network and all the connections your network might make to other networks. Are you in charge of a single local area network, or are you responsible for more than the local area network? Perhaps form a wide area network. What kind of and how many interconnections do you have? Will you have servers that need to be accessed by users on the internet? Is the cloud or virtualization involved? And will you need to share information with company employees who work from home or within or with other organizations, while securing that information from the average user on the internet? The more interconnections and network zones that you have, the more security risk you are taking on. LAN versus WAN. A local area network, or LAN, is a group of networked computers contained in a small space, such as a small office or school, or one or two close-knit buildings. Generally, the computers in the LAN are all assigned private IP addresses and are behind a firewall. Although computers on a LAN do not have to connect to the internet, they usually do so via a router that acts as an IP proxy and employs NAT. NAT is far more common on IPv4 networks, but not unheard of in IPv6 networks. It's important to secure computers on the LAN by placing them behind the router, assigning private IP address if necessary, and verifying that anti-malware programs are installed. A wide area network, or WAN, is one or more LANs connected together. The big difference between a LAN and a WAN is that a WAN covers a larger geographic area. This implies that the services of a telecommunications or data communications provider are necessary. The security implementations of a WAN are great. The more connections your network has, the more likely attacks will become. All connections should be monitored and firewalled. If possible, consider that there might be connections to other states or countries to the biggest WAN of them all, the internet. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.